All right. Welcome, everybody, to the first episode of the Foxglove podcast. We're coming to you live from the Foxglove Studio. With me, I have Jacob and John on the team here. So I guess, Jacob, you want to introduce yourself?
Hey, I'm Jacob, Bandes-Storch, JT Bandes on GitHub, the one with the weird black and white swirly logo. I've been at Foxglove since close to the beginning, not quite as long as Adrian, but John and I started both around the same time, February 2021. Is that right? 2020? Anyway.
Yeah, I think so.
Before that, I was at Cruise working on WebViz, which is a precursor to Foxglove Studio that some of you may have heard of. We can get into that a bit later. I guess I see you have a question here. How did you first get into robotics? I did some programs in middle school and high school with the US FIRST organization, so the Lego Robotics in middle school and the First Robotics, FRC, First Robotics competition in high school, which is a national kind of competitive robotics thing. I think my coding skills have improved since back then, I hope, but that was definitely what got me into it.
Cool. Awesome. And John, you want to introduce yourself?
Yeah. Hey, I'm John Hurliman, J Hurliman if you see me on Slack or GitHub or some other platform online. Like Jacob said, I joined around the same time, and before Foxglove, I was at Verdant Robotics. Got some dogs around here. I was at Verdant Robotics working on agricultural robotics, and we all worked together at Cruise Automation building self-driving cars. And that was really how I got into robotics. It was about 5 years ago, I think, that I saw some early prototypes of self-driving cars in San Francisco and got excited and said, well, I have a background in simulation, and I'd love to see how I can apply that into the robotics field. And since then, I've sort of gone into a whole bunch of different little facets of robotics, but I still am passionate about simulation, 3D rendering, and that side of things.
Cool. What were you, and before joining Cruise, what were you working on? You said you had a background in simulation.
Yeah, so I've done a few different projects and I guess academic research into massive simulation for what was called heterogeneous computing. So if you have everyone is in different areas and they want to look at a shared simulation, but everybody wants to interact in with this. So I want to push a ball and everybody else sees the ball move. So this is a problem that describes online gaming, but it can also describe a large-scale evacuation training, or it might be a giant NASA simulation of something in space that people want to change parameters and have everybody view what's going on. So I was at Intel in a little research group publishing on this topic.
Cool. And you did a bit in the gaming space as well, right?
Yeah, I've had the chance to work in mobile gaming and doing some prototyping for desktop, most of it mobile. So a lot of time spent thinking, how do you get every last bit out of a constrained device's CPU or GPU?
Awesome. Cool. Well, so the topic of conversation today is the new Foxglove Studio 3D panel. So excited to hear a little bit more about how that came to be and what's new about it, why it's better, and what some of the challenges were. So I thought, first of all, Jacob, since you've been working on sort of Foxglove Studio and WebViz even at the early days of Cruise, maybe it'd be interesting to start just by sharing a little bit about how did the previous the old 3D panel come about, and how long has that been a thing?
Yeah. Well, I guess I don't know if everyone who's going to be watching this knows what WebViz is. If people have found us just on the internet as Foxglove. Foxglove Studio began as a fork of a project called WebViz, which is similarly a web-based visualization tool. It's kind of in the name for robotics data that we developed at Cruise. So I was part of the Roman, who's also on our team, and I were part of the original team that during a hackathon at Cruise, I think it was maybe 2017 or 18, fall of 2018, something like that, we decided to get together and sort of prototype, can we make a web app that does all of the visualization tasks that people have been struggling with at Cruise with all their desktop-based tools where they have to drag and rearrange windows on the screen, and then once they've gotten their perfect configuration, it's difficult to share it with a team member and stuff like that. Those were some of the problems we set out to solve with the original WebViz project. And Foxglove Studio from there has evolved in a bunch of different directions, which I don't have time to go into all the details, but we have an extension API, we have a data platform where you can upload data and stream it back into the app, only the parts that you need. We've got a port to TypeScript. Anyway, that's a whole other podcast in and of itself. But I would say that the 3D panel was one of the very first things that we got to work. It was part of the original hackathon that, a few days that we were spending working on the early prototypes of WebViz. We had a 3D panel. I think it may have actually been written in 3JS, the original version of it. And then shortly thereafter, migrated to using Regal. So yeah, I think the 3D panel and maybe a version of the state transition or plot panel were some of the very earliest things to come in. So that code had been around for quite a long time and had grown organically. It had tons of features. I think it was probably the largest panel by lines of code in the app. And it did a lot. And the new one does too, but hopefully in a lot fewer lines of code.
Yeah, yeah. Were you around for any of the early, or were you involved with the early technical choices behind Regal? I guess can you speak to any of the? Do you remember any of the discovery that happened there and how?
I'll try to remember. I believe that there were some performance issues that we had found with the 3JS implementation early on, and just handling lots of messages coming in rapidly when the bag files we were working with got large. We would run into some memory leaks and issues like that. And I believe that's part of what drove us towards using Regal. Some of them it's a little bit more direct, like low-level WebGL wrapper. It's a library that's kind of just wraps WebGL and makes it a lot easier to use, but it doesn't go as far as abstracting into like a scene graph like 3JS does, which is the library that we're using for
right. And then there was also a library called Worldview, right?
Yes, that's right. So I think we started building some stuff in Regal, and that was maybe in the prototype phase, and we realized, okay, it's so low level that it's actually a bit hard to write a real featureful panel on top of this. And so since the rest of the app was built in React, and we foresaw using React for everything in the foreseeable future, we decided to write a little React wrapper around Regal, and so that's what became Worldview. Worldview is also part of the WebViz open source project. And yeah, so it sort of allows you to use React style declarative programming where you have your like Worldview object, and inside that you've nested your cubes and your whatever else you want to render in the scene. And that architecture, I think, made it quite easy to write simple scenes, but it did become challenging when you try to build a more complex panel on top of it.
Yeah.
It also allowed for some cool, I'm actually going to show off the shirt that I'm wearing here. This is an original WebViz t-shirt. This was actually created sort of on a weekend. There was a weird requirement when we were getting the shirts printed that we needed to have vector files, like an SVG or an EPS file, to send to the printer. So I sort of took a weekend and hacked up Worldview so that those React elements, instead of becoming render calls in the Regal API, they would become SVG elements, and it would produce one giant SVG, and that's how this shirt came to be.
Awesome. I imagine also the legal team had a word with you about what kind of data we were sharing on the t-shirt.
Yes, that was something we had to sort of check over, but since I think it would be a little hard to get back to some of the original data from the shirt. If someone wants to reverse engineer the shirt, they probably deserve those algorithms.
Awesome. Yeah, so that's a little bit about, I guess, the backstory of how the 3D panel came to exist and how Foxglove Studio came to be using it. I guess, John, you were one of the larger advocates for taking on a rewrite. Do you want to speak to some of the challenges that we were having with the 3D panel that have been around for the past sort of 5 years?
Yeah. A lot of it really does trace back to that it was the first real panel in WebViz and then in Studio. So it had the most complexity, the most features, and so two parts to that. One is that going in there and making a change was fairly challenging. There was a lot of sort of structural debt that had been baked in by layering features over the years. But also really, there was so much complexity in that panel that we wanted to bring that out of that particular panel into the app. There's a whole topic picker that was pretty elaborate. And we said, there are other panels that would benefit from being able to have a large configurable list of editable settings or displaying topics or toggling things on and off. And so we built this settings API that went into our extension API. And now that topic picker has been pulled out of that particular panel, and you can go build one in any panel.
Right.
We also at the same time said, well, we have this extension API, but we're not actually using it for a lot of our internal panels. So we're not dogfooding this as well as we could. What if we rebuild the 3D panel to actually use our own API? And make sure that you can build complex panels using this. And so that was a good driver for improving the extension API. So so today our new 3D panel is fully using the extension API to run.
Right. Cool.
So being able to pull some of that complexity out was one of the drivers, but we also talked about performance and about just adding new features. When we'd go in and think of a new rendering approach and say, oh, I have an idea how we could make point clouds run faster. Being very low level, like REGL, is a double-edged sword. It can make it very easy to go in there and directly manipulate a shader and say, okay, I can test this low-level tweak. But if your change is a little bit higher level and it would benefit from actually having a scene graph and being able to quickly regroup things or reparent them or take advantage of some of the existing 3D code that's out there for different rendering techniques, that's where 3JS really shines. There's lots and lots of different people doing experiments and sharing techniques and sharing different approaches that we can go draw from the open source community. Versus having to kind of invent each approach ourselves.
Right.
So that was one part that we found appealing about going back to 3JS.
Yeah, if you want to learn how to do something in Worldview, or you encountered a bug and things aren't rendering as you expect, if you Google it, you're not really going to end up with any examples or any other people who've run into the same problem before. So that's a good thing about the new panel.
Right. Well, Worldview itself was sort of a whole separate library that also needed maintenance, and I think we had a fork of Worldview, right?
Mm-hmm. Yeah, we've made some bug fixes there as well.
Yeah. And I mean, I also remember, John, when we were adding adding functionality to the 3D panel. Like I think it was the grid layer was one of the ones where you sort of were. I think you can speak to it, but I think some of the things like that where it was much more difficult than it needed to be to add new types of renderables to the scene.
Right. We were realizing the old 3D panel was very topic centric. It was built around the Ross concept of I have topics coming in and I want to visualize them. And if we wanted to inject new things like I want to load a Urdf from my or a mush file from disk, or I want to create a grid that doesn't act by a topic, we were really having to kind of retrofit them in using synthetic hidden topics or kind of funny different approaches that was adding to our tech debt there. And so in the new scene, we said let's actually just create a API internally in the 3D scene for adding new renderables. So the concept of I want to just go add a grid, I want to add this new layer, is baked in as a first-class concept rather than being sort of backported in there.
Right, right.
There's on the performance angle, there's also one kind of tangent that's worth mentioning around React specifically. So React was designed to improve performance of a lot of common web development tasks. You have data coming in, and I need to make some sort of cascading transform to my view. Well, this data now changes this button, which changes this thing, which maybe has this other effect. And so being able to take small data changes coming in and have these larger scene graph or DOM changes applied efficiently with a diff makes a lot of sense. When you apply that same idea to a large 3D scene with very dynamic data coming in at high frequencies, some of the assumptions about how React makes things faster can flip the other way. So now I'm spending most of my time creating temporary objects, doing these diffs, and then ultimately ending up rendering a new frame regardless because I have high frequency data coming in. And so we made the conscious decision to switch away from React for the majority of actually 3D environment updates because it wasn't the right fit in that particular case.
Yeah.
Is it also, I mean, React seems to me something that is sort of, easy to hand author when you're using JSX or TSX. It's sort of specifically nice that you can kind of create these elements manually by hand. But in the context of a 3D scene, I guess you're largely programmatically creating it based on things that are coming in through the topics, right? Is that, was there any awkwardness there?
For using React or switching away, you mean?
Well, for using React, I guess, like if you're using worldview specifically, worldview gives you a bunch of primitives where I can just do angle brackets cube or something using kind of a JSX syntax. But in reality, when you're rendering a 3D scene, you're never doing that. You're always creating them dynamically based on what's coming out of your file, your local file, or your live connection, right?
Yeah. Maybe not that particular aspect, at least I thought. You're always doing some transform. You have data coming in like a message. It says like cube list message. And now I need to transform that data into something. That could be into angle brackets cube. It could be directly into GL calls. It could be into what we call a renderable, which is sort of sits on top of the 3JS object concept. But we're always applying some transform there.
Right.
But the questions are in the details, like how are you regenerating that each frame, or are you applying updates to it, and how easy or hard is that, and what are the performance implications of each path?
Right. Right. So it sounds like some of the main kind of technical advantages of the new 3D panel switching to 3JS brought us a bigger community and more projects that we can interoperate with there. And also this thing about getting away from like being topic centric and allowing us to add renderables that are not tied to a topic. Were there any other kind of main architectural changes?
I was going to add that I see the move away from React as a positive thing in this case, because not only for performance reasons, but just for being able to mentally reason about when things are going to render and what the performance impact of a new message coming in, like how much code is going to run. With React, React sort of handles that for you, and that's kind of the beauty of it. If you're writing simple enough things, you just update the property that you want to update, and somewhere else in the tree, things will re-render. But if you want specific control over which parts are memoized, or in Studio, I guess when messages come in, we have some challenges with making sure that all the rendering has actually occurred before we move on to the next batch of messages, so that we never have some kind of tearing and showing different data on screen. And that kind of stuff was really hard to reason about when we had the React wrapper in the 3D panel.
Right. Having very fine-grained control over what updates are going to trigger which GL calls is beneficial when we're handling the sort of high data, high performance scenario.
All right, cool. And then I guess moving on to sort of what is different feature-wise about the new 3D panel. you hinted at one of the things, John, around how we handle the topic list. Do you want to sort of just speak a little bit more to that and the thinking that went behind it?
Yeah. We had this early vision that was inspired by looking at the 3D panel, but really extends out to all the panels and just how we think about the app, which is we saw settings, per panel settings, were really sort of ad hoc. Oh, this panel has a little pop-up, this one has these inline controls, and this one has a topic picker in it. And we said, it'd be really nice if we unified all this and just had a consistent interface for every panel that you go into, whether it's some person's custom extension or whether it's our own native panel, has the same consistent UI for how do you modify the settings for this. And so we came up with the settings API, which gives you this settings sidebar. And for the 3D panel, the new 3D panel, it's quite complex. Every topic shows up there. Every topic has per topic settings that you can override. Well, other panels might just have like a single sort of drop down of like, what's my input topic or something like that. But having the single API that we can create this in really allowed us to go a lot further with the depth of different settings that we could have. There was always friction in the old 3D panel of like, oh, I got to add a new setting. I'm going to have to touch like 8 parts of the code and test all these things. And it was a challenge, but in this one, it's fairly straightforward to add a new field. And so while we were doing this port, we wanted to make sure we supported everything that existed there before, but we also went further and started adding more customizability. And I think the floor is open now that we can keep running with that. There's no reason that we can't have 10 or 15 customizable fields on each topic. We're limited more by overloading the user now, rather than overloading the devs.
Yeah, I guess one of the main things there was that you should be able to edit the scene without covering up the scene. And I remember in the old 3D panel, not only did the topic list kind of cover up half of the scene while it was open, but then if you wanted to edit the settings of a particular topic, that would throw up a modal, I think, and it would just completely cover your entire app. So that would really block you from being able to see, well, if I'm editing, the color of my point cloud, I should be able to see that change happen in real time without it being blocked.
That's a good example right there of a UI overhaul that we did that hopefully will benefit all of the panels in the app.
Yeah, I'm just sharing this is what it looked like in the old 3D panel. We've had this modal and the list of topics that sort of overlap the contents of what you're trying to look at, and then if we replace it with the new 3D panel, the settings are now here in the sidebar. They sort of push over your layout,
right,
so that you can see them at the same time.
And another big architectural change to the 3D panel that we use the settings panel to enact was at the bottom we have this idea of custom layers. I was mentioning before, if you wanted to add a grid, it was like, okay, well, we have to create like a fake topic, and then what if I wanted 2 grids? This is confusing. Now we just have this idea of I just want to add things to my scene, and what we have in the app today is like an early preview of what could be done here. You can add an arbitrary number of grids, attach them to different frames, different colors, which in of itself we found we were just using this for debugging a challenging transform hierarchy the other day, but you could imagine a list that's longer with adding, I want to add a mesh off of a 3D model off of my hard drive. I want to add some programmatic primitives that maybe aren't represented in messages coming in, but I just want to kind of do some scene layout.
Right.
I want to load map tiles or GeoJSON off my disk. So hopefully we add a lot more to this list and give you a lot more flexibility.
And then besides kind of the big settings changes, what were some of the other features that have been added to the new 3D panel? I think the image rendering is one that sticks out to me.
Yeah, the image rendering was a good example of something that was sort of sitting in the backlog a little bit of we want to add this. It's a neat feature, but the challenge of plumbing it into the 3D scene is kind of creating some friction there. So once we had a fresh slate, that was an easy renderable to drop in.
Right.
It takes two input topics to work under the hood. You need the camera info, which describes the geometry of your camera, the intrinsics and its pose, and then you need the actual image data. And it takes those two things to create this warped representation of the image plane in space and projects it some distance out. And so
Right.
now
So
you can
let's
get a video
actually
where you drive.
Yeah, seeing a camera image in the 3D panel.
And this is a little hint as well as what's possible with the image panel. So you can see here we're clearly rendering an image, and we're rendering markers in space in front of it. So it should be possible to go refactor the image panel to fully support 3D markers or more advanced overlays in that panel using the technology we built here.
Right. That's been a common feature request for quite a while, is to be able to render 3D elements like point clouds and markers into 2D camera space. The other one, maybe Jacob, do you want to speak to some of the work that happened around bring your own data and the Foxglove schemas in the new 3D panel?
Yeah, so just to give a little overview of what that project means and why we're doing it. Probably many of you listeners are using ROS, and we find that that's a really common robotics framework that I would say the majority of our user base is on ROS. However, there are still many companies and many individuals and research groups, et cetera, who are not using ROS and are either building their own software stack or are assembling pieces like Protobuf or Avro or Arrow or all these other kind of message formats and message passing layers, like 0 and Q, that kind of thing. We wanted to allow all of those people to use the same features of Foxglove Studio and be able to take full advantage of the 3D panel as well as all of the other panels. So I think the first iteration of that was just taking all of the ROS messages and translating them directly to protobuf schemas. So people who are using protobufs could easily have an equivalent protobuf that if they just produce that message, it'll work in Studio just like the ROS message did. But the evolution of that project has turned into, let's kind of step back and think about what are the features we currently support, what are the features we'd like to support, and which parts of the message, of the ROS messages, does Studio actually use and need to do its visualization. So we ended up defining what we're calling Foxglove schemas, and we have a Foxglove/schemas repo for that. And those are sort of language agnostic schemas for your data, and we generate protobuf definitions from them, but we also generate ROS messages for folks who are still using ROS if we've added any new features and they want to take advantage of it. But if someone is just writing a simple script and they want to use JSON as their encoding, they can also go and use these Foxglove schemas as well. We have flat buffer support and some other things, and we're open to adding more as well. So for the 3D panel specifically, I think one of the largest pieces of work there has been in translating the concept of, in ROS, the marker array, which is sort of, when we stepped back and looked at what Studio actually does with the marker array, we thought, well, this is kind of like describing a scene, a visual scene that has multiple entities in it. It may have some cubes arranged like cars. It may have lines for predicted paths of other objects or whatever you want to represent visually. And so we've turned this into the Foxglove scene entity and scene update messages. And those are supported in the new 3D panel. And so that will allow anyone who uses any kind of software stack to produce these scene entities and get them into the 3D panel.
Would you recommend...
They support a lot of features that are familiar to folks who've used ROS. They support having lifetimes so that the entity can live beyond when it was published and then disappear after a certain amount of time. It supports a lot of the same primitives, cubes, spheres, cones, whatever. But we've also added some support for newer things in there and better types and features around like meshes and some other. We have a grid message, but that's actually not one of the scene entities. But yeah, and like more different types of shapes that you can add and all these things.
If people are using ROS, would you recommend that they check out the Foxglove scene entity Foxglove messages, or would you primarily recommend that as something for non-ROS users?
I would say check it out. I think there are some new features where maybe if you're trying to make a certain shape, and like your cylinder now allows you to specify a different radius on the top and bottom, so it can kind of become more of a cone. Like that's one example of a little detail that we've added for the scene entities that is kind of a nice to have thing. And those are the sorts of changes that we find it'll be a lot easier to make in this new 3D panel if we find any kind of opportunities for that sort of feature going forward.
Right. So these are not supported by the ROS.
Right.
We can and do still render the ROS marker object and marker array, but
yeah, absolutely.
some of those features are not available.
We definitely plan to continue supporting the ROS types in the new panel because we know that tons of people out there are still using ROS, but we've added some nice new features for folks who are willing to use our types.
All right. Cool. And then I guess just thinking about we're sort of, we've come out the other side now. It's been a many month project. What would you say are some of the biggest, or what was like the number one kind of technical challenge that we faced in building the new 3D panel? What were the unknown unknowns now that we've discovered them?
One I can think of just off the top of my head, I don't know if it was the largest one, but maybe most recent was we have this feature to change the follow mode for the camera. You can have the camera stay following a frame, which in the implementation's perspective is actually the default. It's the do nothing. We just we render all of the transforms into a specific frame, and so if the scene is moving around that that frame is moving, the camera just naturally follows with it. But then we added these other options for disconnecting. So, I want to be in this frame, but I want to stay in a static position. So even if that frame is moving away, we're going to stay stationary. And what that's doing under the hood is actually capturing an offset at a specific point, and then every frame we have to go apply a delta offset so that it appears that the camera is just staying stationary, even though we're getting further and further away from the origin. And this is something that was baked, or it was built into the Worldview library, some support for this. And so the implementation for a lot of the things in our new 3D versus old 3D, we're very mechanical, just do this instead of this, call this instead of this. But that one had to, we had to really rethink it from the ground up, go back to the whiteboard on the math and fully re-implement the feature. So there were a few little things where we ran into, we go, okay, we just have to fundamentally re-implement this, and nobody's thought about this problem in a while, so let's dust off the old whiteboards.
Yeah, I would call out also the architecture of how the different renderables are added to the scene is quite different, and is something where we had to rethink, partly just because getting things set up in Three.js is a bit different, and you make this scene graph, and so we ended up with a internal API for now called Scene Extension, where the extension it sort of gets to be a parent object in the scene graph, and all of the, for example, the extension that handles grids, any grid that you add is going to be a child of that scene extension. That was something new for Three.js that wouldn't have worked quite the same way in Worldview, but I think it also gave us the opportunity to think about how we may want to expose some of this to custom user code in the future if people are writing Foxglove Studio extensions and they want to add new sort of custom visualizations to the 3D panel. That's something we've gotten a lot of requests for and are thinking about actively. So this was a chance to explore some of the early stages of what that might look like.
Right.
Yeah, there was both adding things to the scene and also removing things is its own challenge. We talked about memory leaks early on. JavaScript's a garbage, and TypeScript are garbage collected. But in GPU programming and GL programming, you have unmanaged resources. If I create a GPU buffer, no garbage collection is going to make that go away. If I allocate a texture or a buffer full of geometry, I'm responsible for manually cleaning that up. And so there's quite a bit of code and scattered throughout the whole new 3D panel for manually managing these resources. We have to think about creating things and also when do we throw these away.
And is that something like just 3JS make that easier or handle any of those instances for you, or is this just sort of something that anyone doing 3D programming for the web has to deal with?
So they have a pattern of putting a dispose method on objects, and so you can check the type signature for an object and see if this has a dispose method that suggests that it's handling some unmanaged resources, or some child object of it somewhere has an unmanaged resource. And so we've copied that pattern, and so anything that has a dispose method needs to have that called. But it really just requires a code organization or thinking about how and when do I call the dispose method on every relevant object.
Right. Interesting. Cool. And so looking to the future, I guess, what are some of the things that are on the roadmap for the 3D panel now that it's shipped?
Well, one thing that we talked about a little bit already, and is maybe not quite for the 3D panel, but rethinking the image panel to support 3D markers on images is definitely something that's there. In the nearer term, we are also looking at the sort of custom rendering for certain message types. As people have, perhaps they have a drone that records some latitude and longitude data in a custom format, and they want to display that in Foxglove Studio and not have to write some sort of step in their processing pipeline where they translate their recorded data into a ROS message or into a Foxglove message, but being able to write more of an extension or a plugin to Studio that does the transformation live. That's something that we're looking at now that'll definitely be associated with the 3D panel. It may also support other panels as well, but it would be a big help for 3D panel.
Yeah, I think that's been a long-standing feature request, is sort of how do I teach Foxglove about my own custom data types.
Yeah.
Today that requires sort of you explicitly publishing some Foxglove messages or some ROS messages.
Yeah, we also have some low-hanging fruit around common message types, like IMU messages, odometry. I think we're maintaining a list and an issue of renderable types that we really should just natively handle. And it was a challenge before, but the road should be very clear now to just go add a lot of those in short order.
Awesome.
Yeah, I mean, that's to be a little more clear about that. Partly the answer to the question is driven by user interests and user requests. So if you out there have a message type that you particularly think should be added to the 3D panel, that's a common format that others are also using, then let us know.
Yeah, definitely. We love feedback, and there's quite a few GitHub issues that I think now that we have the new 3D panel out there, we should be able to add support for a lot more common message types a lot faster, right?
Yeah.
The other thing that I thought was a roadmap item, but I just learned that we actually already shipped, was transform editing.
Yep.
Oh, yeah, that one went in fairly quickly, and so I don't think it got the accolades that it deserves, but it's pretty powerful. You can now go flip a switch in the new 3D panel, and in addition to seeing the XYZ roll pitch yaw of all of your transforms, there's another set of offsets. So you can apply these fixed position or rotational offsets to your transforms. So this is the first time that I've seen what you could call like a live Urdf editor. You load up all your transforms into Studio, and you go, oh, this one's like a half a meter off, and you can just visually slide it over or change the orientation. and that you might be getting it to line up with point cloud data, or you might be getting it to line up with like a model that you've loaded. But you can do that right in the app, and you can see the new values and then go put them back into your Urdf or into your messages.
And so what is the main workflow? If someone wanted to use this, what would they be sort of bringing to the table, and what would they be trying to get out of it?
Well, so imagine the workflow for editing or creating a URDF. Previously, you might start in your CAD software and you've laid out your robots geometry, and you manually sort of extract out, okay, here's the offset and pose of this particular camera with relation to my rear axle or the base of this moving robot or the middle of my drone, whatever it is. And you load it up and you go, oh, shoot, wait, it's upside down. And so you go back and you fix it. Or wait, this is a meter off. This is totally wrong. And so you go back and edit your file, and then you load it up again, and you see we're cutting one step out of that workflow, where now you can just visually go, well, what if I inverted this value? Or what if I slid it over by a meter? Oh, yeah, that fixes it. Okay, let me go put that in. So just as if you imagine in programming REPLs, where you can interactively type expressions and see the results, cut down a lot of the back and forth. I don't have to go compile my program, run it, see the output. I can just interactively work on something. That's what I hope we can do with 3D scenes.
Awesome, cool. Well, any parting thoughts before we head out here?
I just reiterate that we love getting feedback, and if folks are running into issues or just really enjoying the new 3D panel, I think we'd like to hear about it and see some cool demos. Our public Slack organization, which anyone is welcome to join, has a show and tell channel where you can come and post images or recordings or whatever to let us know what you've been working on. We'd love to see it.
Yeah, a lot of the work that went into this new 3D panel was really to get us set up. I would say this is the beginning, not the end of shipping the feature. And so people have new ideas of how to extend this or what they would like to see next. Now's the time.
Great. All right. Well, yeah, thanks for joining me, guys. It was great learning a bit more about the history of the 3D panel and the new 3D panel and some of the things that are on the roadmap. And thanks for joining us, everyone who's listening in. And we hope to see you in our community Slack.